Howdy everybody, Kamikaze Avalanche here. I wanted to do, this should be a shorter practical tutorial, and I just wanted to show you one of the advanced debugging techniques I used to kind of step through and resolve a problem I was having that maybe would be helpful to you. And this debugging technique is I'm going to be using a signal and I'm going to be emitting that signal when I press a button because I want to advance through a loop one at a time to see the results. And I don't want to create a breakpoint because going back and forth between the Godot console and the game is too janky and takes up too much time. So I'm going to be walking through this technique. After talking about a use case for it, we're going to be declaring the signal. We're going to be adding the input map of a keystroke, in this case the keyboard key P on my keyboard. We're going to put an await in the looping code, and I'm going to connect that input event to emitting that signal. So let's take a look at this one. And the scenario that I'm dealing with right here is when the character moves, I want all of the spaces within range for it to do a kind of visibility check. I don't want the player to be able to walk to the other side of an enemy or through a wall or things like that. So I've turned on debugging shapes for this so that we can see how this works. Right now I have this raycast right here, and it's a red line because it's colliding with the walls. Here you can see the exact same thing. This spearman, he does a visibility check. For the spearmen, it doesn't really matter. It actually only matters for the archers because they can shoot at range. The spearmen will be adjacent anyway, so they will have visibility. But you can see how this archer's raycast is blue because he's not colliding with the spawn point. However, if he was one square lower, his visibility would be colliding with the wall, and that would be no good, and I wouldn't want the archer to be able to shoot from this space to this space if I was standing right there. So walls do provide protection in my game. So let me step through and show you what it looks like. So when I move, what I'm doing is, first let me give myself 3 movement points. When I activate for movement, I'm going to step through and I'm going to add all of the tiles that are within range and aren't blocked by terrain. And then I'm going to step through the center of the tile for each tile and then see if I'm colliding. So if this is blue, I'm going to add it to the spaces that they can move to. And it's gonna, I have a movement range of 3, so 1, 2, 3 spaces, so it's checking. And I'm hitting the P key to advance it. So I'm actually going to move my hero, and let me do that again when I'm away from the wall. So I'm going to click on my character to advance for movement, and it's going to add some squares automatically if it considers them adjacent. It automatically adds them and doesn't do the check with the raycast. So when it hits that square, it's just going to add it if it's adjacent to the hero. So here we can see the raycast is going down there. I'm going to press P to advance it, P to advance it, P to advance it. It added this square automatically because it was diagonally adjacent. This one is not, so it's going to, I'm going to have to press P to advance the code. That one was adjacent, P, 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 and those squares are adjacent, and I'm done with the checks. So If I was putting a breakpoint in the code, I would have to jump back and forth between the console every single time, and that's not something I want to do. Maybe I just want to check something in a for loop, and I just want to spam the P button to move forward. So that's kind of the use case that we have to look at here. And an example of how I use this code, let's go ahead and quit out here. So first things first, I had the collision shapes visible for that example. I'm done with the process of debugging, so I'm going to turn that off. All right, so we've talked about the use case. The next thing I want to do is declare the signal. Now, you've probably seen a tutorial that has an event bus, and the event bus is an auto load, and it's just a collection of signals. And you're going to call to that event bus when you're emitting, or you're going to connect to that when you're connecting to that signal. But in this case, since I'm just using this signal for debugging, there's no need to use the event bus on this. I know that the code is going to stay all within my player script. So instead of using the event bus, I'm just going to create this signal at the top of the code like I would a variable, and I'm calling the signal input pressed. So I'm declaring the signal input pressed. The next step that I want to do is I want to add the input map. I want to add the letter that I'm going to use. So in this case, I've got the letter P. I'm calling it P, and I'm going to get rid of this, and it's not going to be used in the final code. And I don't use the letter P for anything else. So input map, I created a new action, named it P, right? Clicked add. It's not going to work because I already have it. And I added the button press of this for P. The next step, step 4, is I want to put the signal, I want to await for it where it is in the code. So in here, this is the functionality that checks each of the tiles for if it's colliding. So we can see in this script, it's given each of the tiles right here as a vector 2i. It is calculating the direction and then pointing the raycast to the center of that tile. And then here's the magic code, await input pressed. So here I'm awaiting that signal, which I have no way of generating at this point, but that's the 5th step here. So I'm awaiting. So you saw in the demonstration where the raycast was sitting at that tile until I pressed the letter P. When I pressed the letter P, it returned false in the cases where it was an open space, or returned true and then said it was colliding in the cases where it actually did have a collision, so we wouldn't be able to see it. And then it would go, and if it was false, it would add the tile, it would draw it in as a tile that we could move to and add it to the array of movable tiles. So here, this is the 4th step. We are awaiting that signal to be emitted. The final step in this process is I have the input function already. I just added 2 lines of code right here. I say if event.isActionPressed, and it's P, and remember that the P in this case stands for anything that's added here. I could add a mouse stroke, I could add one of those odd mouse buttons if I wanted to use that mouse button just for debugging, but in this case the keyboard stroke of P is fine for me. If the event is a P, I'm going to emit the signal. And there you have it. A simple 5-step process for using a signal, connecting it to a keystroke to iterate through a looping code or repetitive code for easier debugging. Now, just how the story ends here. In this case, the problem with my code wasn't resolved by doing this because the problem was my code was resolving too fast. And so I actually had to add a delay into the code and wait for I had to call defer so that it would await other things processing in the background. But because I didn't see the problem occur when I had these delays, I actually did figure out that I needed to add those delays. So long story short, it did help me, but not in the way I expected. However, I hope this is a tool that you can add to your toolbox. It's basically 4 lines of code that could help ease your debugging process. So take care, and I hope you picked something up with this quick little tutorial. Bye.